At 2:47 a.m., Russian defenders at Novorossiysk suddenly lost their harbor's eyes. First, Beaver airburst drones blinded Panzer S-1 air defenses, and a fragment haze forced a Ka-27 helicopter to abandon its search for threats below. Overloaded by a diversionary decoy swarm, Russian sonar teams hesitated, unable to distinguish real danger from artificial echoes. Through this engineered sensor collapse, a Toloka TLK-150 unmanned underwater vehicle slipped past layered defenses, exploiting the submarine's baffle zone, the one acoustic blind spot, before severing the Kolpino's propeller shaft with a focused charge. This is asymmetric naval warfare in real time. A handful of drones, collectively worth less than $50,000, rewriting Black Sea strategy and sending shockwaves through military doctrines built on expensive legacy platforms. How was every layer of defense neutralized so quickly, and what does it mean for the future of maritime security? Subscribe now to follow the decisive moments that changed undersea warfare. A single detonation shattered the calm at Novorossiysk. The Beaver airburst drone, programmed for precise timing, released a cloud of nearly 2,000 tungsten fragments above the harbor. Within milliseconds, the Panzer S-1 battery's optical and infrared sensors were overwhelmed. Radar screens registered a sudden spike in backscatter, flooding the display with false returns and static. For 5 to 7 seconds, the length of a single breath, the harbor's primary air defense system was blind. Operators inside the Panzer's armored cabs scrambled to reset their targeting, but the sensor suite lagged behind the chaos outside. By the time the system cycled back to operational status, the critical window had closed. The Toloka TLK-150 unmanned underwater vehicle had already begun its run, exploiting the temporary blackout to slip past the first layer of defenses. The missile battery's response was delayed, its automated fire control unable to lock onto anything moving through the fragment haze. That brief sensor collapse marked the first breach of the harbor's protective ring, opening a path for what came next. Rotor blades cut through the night as the Ka-27 anti-submarine helicopter closed in over Novorossiysk harbor. Seconds after the airburst, a dense haze of tungsten fragments and dust drifted across the water, scattering infrared light and saturating the helicopter's sensors. The crew watched their screens bloom with static, thermal signatures washed out, visual feeds flickered, and the magnetic anomaly detector lost coherence. Standard abort criteria for the Ka-27's infrared suite triggered almost instantly. With sensor readings below safe thresholds and no reliable contact on the water's surface, the pilot called for immediate withdrawal. The helicopter banked away, leaving its assigned search sector exposed. In those critical moments, anti-submarine coverage over the harbor vanished. Russian doctrine relies on rotary wing patrols to detect and intercept underwater threats, but the fragment haze had blinded the Ka-27 before it could deploy sonar or depth charges. The corridor to the inner pier now stood open, with no airborne eyes left to track what moved beneath the surface. A sudden burst of false echoes rolled across the sonar displays inside Novorossiysk harbor. The Russian operators, already on edge, watched as their screens filled with overlapping acoustic signatures, some sharp, some faint, all moving in unpredictable patterns. Each new contact forced a decision: real threat or harmless decoy. The Toloka TLK-150 was not alone in the water. Multiple low-signature decoys, programmed to mimic the acoustic profile of underwater vehicles, flooded the harbor's sensors with artificial noise. For the sonar team, the workload spiked. The system's filters struggled to distinguish between genuine intrusions and the swarm of imposters. Probability-based tracking algorithms began to discard contacts at random, unable to keep up with the surge. The operators hesitated, uncertain which signals required immediate action. In this confusion, the sonar picture became nearly unusable, a wash of overlapping blips and phantom trails. The defensive net, designed to catch a single intruder, was now saturated. Amid the chaos, the true threat moved silently, exploiting the overload to carve out a clear path toward its target. The Toloka TLK-150 entered the harbor beneath the surface, guided by a preloaded set of acoustic waypoints. Its hull, just 2.5 meters long and 40 centimeters wide, made it indistinguishable from the clutter of harbor debris on sonar. The electric drive, engineered for minimal vibration, produced less noise than a running outboard motor. Each movement, including rudder shifts and depth adjustments, was calculated by its onboard autonomy module, which weighed the risk of detection against the need for speed. The mission profile allowed no return, and the payload, between 20 and 50 kilograms, was configured for a single strike. Recovery was never part of the plan. Inside the unmanned underwater vehicle, a compact guidance system tracked distance to each waypoint, adjusting course to avoid obstacles while maintaining a steady 3 knots. The hull's small cross-section and absence of external fittings reduced its acoustic signature to a bare minimum. Toloka's designers accepted a trade-off: limited endurance in exchange for near silence. This balance kept the device below the threshold that would trigger automated alarms in Russian sonar arrays. The vehicle advanced toward the inner harbor, its course set for the stern sector, where the submarine's own sensors left a narrow acoustic blind spot. A berthed submarine is not invulnerable. Even at anchor, the B-271 Kolpino's hull casts its own shadow, a region directly behind the stern, where the submarine's own propeller and machinery noise drown out incoming sounds. This is the baffles zone, an acoustic blind spot that anti-submarine sensors struggle to penetrate. Russian sonar arrays and hull-mounted hydrophones rely on clear lines of acoustic sight, but the geometry of the harbor and the submarine's position create a wedge where detection becomes unreliable. The Toloka TLK-150 exploited this gap, approaching from astern, where neither the Kolpino's sensors nor the harbor's defensive net could track a low-signature intruder. The UUV's electric drive and compact hull made it nearly invisible within this shadow, blending with background noise and harbor clutter. No alarm sounded. No last-ditch alert reached the crew. The environment itself became an accomplice, masking the UUV's final approach as it closed the distance to the propeller shaft. In this narrow corridor, the geometry of the harbor and the limitations of sonar left the submarine exposed, setting the stage for the strike that would follow. A shaped charge, engineered for precision, detonated beneath the stern of the B-271 Kolpino. The Toloka TLK-150's warhead was directed squarely at the propeller shaft coupling, a known mechanical vulnerability in Kilo-class submarines. In less than a second, the explosion focused its energy into a narrow jet, punching through the shaft's steel housing. The force was enough to shear the coupling and twist the shaft out of alignment. With the shaft severed, the submarine's primary means of propulsion failed instantly. The electric drive, now disconnected from the propeller, spun uselessly. Emergency procedures on board would have called for immediate compartment isolation. But the blast's geometry also breached the shaft tunnel, allowing seawater to flood the machinery spaces. Even at dock, this kind of flooding can overwhelm pumps and force a rapid shutdown of all non-essential systems. The Kolpino, valued at nearly $450 million, was rendered immobile by a single device costing less than a family car. In the span of a few heartbeats, a strategic asset became dead weight at the pier, its mobility erased, its combat role finished. The numbers behind this operation tell their own story. The B-271 Kolpino, an improved Kilo-class submarine, carried a price tag close to $450 million, reflecting years of engineering, maintenance, and crew training. By contrast, the combined cost of the Toloka TLK-150 unmanned underwater vehicle and its supporting drones came in under $50,000. That is a ratio of nearly 9,000 to 1. From a budget analyst's perspective, the equation is stark. A single low-cost drone package managed to sideline a platform that once anchored Russia's Black Sea deterrence. The Kolpino represented a major investment in stealth, firepower, and survivability. The Ukrainian strike team spent less than the price of a new SUV to erase that investment in seconds. This kind of cost differential does not just sting, it forces every military planner to rethink the value of expensive hardware in an era where disposable systems can deliver strategic effects. The aftermath at Novorossiysk triggered a sweeping review inside Russia's naval command. Within weeks, satellite images captured new boom barriers stretching across the harbor mouth, heavy steel pontoons anchored in place, designed to block underwater vehicles from slipping inside. Barges were repositioned to create layered physical obstacles, while procurement orders surfaced for advanced harbor sealant systems, earmarked at roughly $150 million in the revised defense budget. The focus shifted to countering low-signature threats. Contracts for next-generation Pantsir S1M batteries promised hardened electro-optical sensors, less vulnerable to fragment clouds and electronic interference. Distributed basing became a priority, with plans to rotate assets between Novorossiysk, Tuapse, and outlying anchorages, reducing exposure at any single port. These changes signal a new era for the Black Sea Fleet, one where the pace of innovation and adaptation determines survival. Each adjustment is a response to the reality that high-value platforms can fall to small, inexpensive machines, and that the contest between offense and defense is now a race without a finish line. Today, a $450 million submarine can fall to $50,000 worth of drones. As unmanned systems like the Toloka TLK-150 and Beaver redefine naval warfare, expensive platforms face unprecedented vulnerability. Asymmetry is now strategy, not anomaly. For the Black Sea, balance shifts with every innovation. Subscribe for more frontline analysis.